Hello everyone, my name is Rajesh Kumar and I'm your DevOps SRE DevSecOps coach. I have close to 18 plus years of experience working in multiple MNCs around the globe and having in-depth knowledge of DevOps, SRE and DevSecOps. So I would like to introduce you one certification program in a DevOps, and that is we call it DevOps Certified Professional. Now this is a 2 months of program, 25 tools of DevOps you will learn, and apart from that you will also get the access to the LMS, lifetime access to the videos portal. It's a certification program, and you will have 25 assignments and 2 projects along with it. It's a completely weekend program, so here you have classes on Saturday and Sunday. So as part of this course, you will learn multiple things. Here you see that you will learn Linux, AWS, Docker, Jira, Confluence, Python, Git with GitHub, SonarQube, Maven, Gradle, Packer, Artifactory, Selenium, JMeter, Ansible, Kubernetes, Helm, Terraform, Jenkins, Datadog, Splunk, and Neuralink. Now, how do we, apply for this? So how can you reach out to us? So you have a WhatsApp number and email ID, so please reach out to us and we'll help you to onboard this program. Apart from this DevOps certified professional programs, we are offering other certifications as well in a DevSecOps, SRE, and one of the very comprehensive programs which we have is in Master in DevOps Engineering. Yeah, so feel free to get in touch with us and then enroll for it. Thank you. Hello. Hello. Yeah. So now after the deployment, next service we have is service itself. What is service? Service is like a network load balancer for pod, because here you saw that I created so many pod. Okay. So how can we load balance? So let me scale this pod to the edit the pod, edit deployment again, and make it 5 1 again back to 5. Yeah, save it, and you see here you got a 5 pods here. So the question is, how do we load balance these 5 pods? Is there any way? So the answer is service. Service, using the service we can load balance the pod. Okay. So how it works? So let me tell you. First, let me create this service. So kubectl get svc. So there is no any other service except this one. Because of this service only, the API server is accessible. So it's a default, but I have not created any service. How do we create a service then? So there is a way to create a service, and that is kubectl expose -h. So this is the command. And now the service you can create for the pod, service you can create for the service also, replication controller also, deployment also, replica sets also. So out of which pod and deployment I taught you, which is the most important one. So how do we create a service? So here I'm going to copy this some code here from here, example code. So let's use this simple one. So here I'm creating a service. Name of the service, service from RC. No, I want to create a service from deployment, and name of the deployment mydep, and service should be accessible on 80 port. Yes, you can change this if you want. And service is load balancing the pod. Pod is running on which port? 80 port, because I know this image is running on 80 port. This one. So now this command will create a service. So let me get it. See here, kubectl get svc. Here, look at this. This service got created. This service IP address, port number is here. Now if you describe this service, it should be load balancing 5 pod. So these are the 5 pod you see here. Okay, so one pod, second, third, fourth, fifth, and all like that. So 5 pod is deploying. So when I hit this service IP address, okay, here one of the pod will serve the request. So http call http 80 port. Now it's not accessible because of some networking challenges in this master node. Let me try same thing in the worker node. See, now there is one pod which has offered the request. You can see that. Okay, so this logic is round robin actually. Okay, so this service is working with a round robin. Okay, so this is a way if you want to load balance the pod. So now what you should do, you should expose this service also. So there is a service created right here, and if you want to access from outside of the cluster, so you can expose the service also. How? You know that here, uh, see, this is exposing the service. So let me try expose the service with service mydep service. The service name is mydep only. Let me show you here mydep, and which is the port number. So service port number which you want to expose outside is, let's make it 80 only, or 8081, and this service you are running at the port number 80, and then name of the service you want to give it this one. That's okay. So that's, I'm now exposing the service also to outside of the cluster, and you see here this service now. Okay, if you hit 8081, this is the one. Let me check this way. So and 8081, see here. Now how do we access this outside of the cluster? So you have to convert into the node port. See this, the type is cluster IP, so it's accessible inside a cluster, but if you want to access from outside of the cluster, then you have to convert into the node port. How do you do that? So let me edit this, and this service I'm editing. Oh, this service also you can convert into node port. So edit svc here, and type will become a node port. So let's make it node capital N O port like this. Save it. Now get svc. So node port means worker node IP address and port number you have here. So let me try this worker node IP address. See you. It's not come actually. IPA more IP address is 31. So 31, enter. See here. So this way it's coming. Okay. So now because of this, you are able to access this out from outside also. Node port, at the node port you can access. There is other way also, load balancer type, but right now I'm not discussing because you don't have cloud infrastructure in this. Okay, so in short, service is basically help you to load balance the net pods in a cluster.
Rajesh, sorry for cutting you short there. Can you please explain the concept of a load balancer here?
A load balancer concept is very simple. Um, uh, Here there is a one pod, two pod, three pod, four pod, five pod. Now this pod is Apache, 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 Apache. Now here this is me. I cannot hit this all IP address of the pod. Very odd actually. So what to do? So I will create one load balancer service the way I touch. This will load balance the pod. Okay. Now this will load balance the healthy pod. Now I don't have to remember the pod IP address. I will hit the IP address of service
Mhm.
if you're inside a cluster. Okay. And then
Mhm.
it will redirect to one of the pod. That is what is happening. So if you see that here, this is service which I created and describe SVC here. See this all the pods is load balanced by this particular service. Got it?
Okay. Oh, okay. So, what is the difference between this load balancer and a reverse proxy then?
A load balancer and
Reverse proxy.
uh, see load balancer is this one, the one which explained it to you. A
Mm-hmm.
reverse proxy, what happens? Traffic uh, here, this is you, and
Mm-hmm.
then you hit to the, let's say, Apache, and there is a one service which you have, one application which you are running, XYZ, whatever it is. So what happens? You cannot reach out directly to this application. So what happened? But this Apache you set it up, which is accessible, exposed to the internet. So Apache will, you hit to certain port number, certain address, and it will proxy that to transfer that request to here, and response also through this.
Oh, okay.
So that is a reverse proxy.
Thank you. Thank you so much.
Okay, so now this is a service. Again, practice it. It will help you. Now, next topic is we have a PVCs and PVs. What is a PVP, PVC and PVs?
But
This,
before you go ahead, in the deployment section, we have the versioning, the rollout, and rollback. You didn't explain those ones.
yeah. So I didn't want it to confuse you. If you practice, you'll get it. So basically, there is a deployment has happened. Okay, and the first time deployment has happened with the image, which we have is 1.1. Then we modify the deployment and created an image of 1.2.
Mm-hmm.
So this is like a changes in the deployment over the period of time. Next week probably you will modify this deployment and deploy 1.3. Right now I have a three deployments. Okay, three versions. So this act of modifying this deployment and their images or whatever it is, this automatic versioning will be enabled here. Okay, automatic versioning. So how do you see that? So let me show you here. QCTL rollout history my hyphen dep. What is this? History deploy my dep. See here. So there's only one version is available right now. So if you change the image, you'll become a two version. Let me change the image. So edit my dep, deploy, and here you have to change the version of image. Here I'm changing the v1 to v2. That image is available, I know that, and you see here 2. So everything which you modify the deployment, versioning is being recorded. Okay. So now what is a rollout and rollback? So rollout means if you modify, there is a one version 1.1 and then you go to 1.2, this is called rollout. But let's say you have a version 1.2 and you want to go back to 1.1, this is called rollback. So for that also there's a command for. So there's a versioning here you 1 and 2. So you want to roll out, roll back for that -h. So here you can undo the things, roll back things. Rollout is just change the image. It will be rollout new version. Rollback is like you can undo the things. So here undo, undo -h. Here you see. uh, see undo to the which revision number. This is a daemon set, but it can be deployment here also. Got it?
Got it. Yes,
Yeah,
thank you.
but one more thing. Here you have all the commands line by line. Kubernetes deployment. So this page, okay,
Mhm.
and here all these explanations you have it here, and then this commands and all you can run it here. Okay, so all this rollback command here, rollout command here. We are for rollout we are just changing the image deployment. That's all.
Thank you.
Okay. Now PVs and PVCs. So the problem with the pod is pod you have container, and you know what happens? Any things which is getting stored in a container, okay, which is inside a pod in Kubernetes, which get container get deleted, so data also got deleted. Okay, pod is gone. Okay, data is also gone. That is a problem what you have. Okay, simple. So the problem which we have is data is not persistence. So how do we make the data persistence? And for that we have a feature called PVC and PV. What is this PVC and PV? Let me tell you here. I'll give you one simple small workflow, then you'll understand this. So you go to AWS, okay, AWS, and then you create a volume. Create a volume. I think you have done it. So volume is created. Okay, volume is created only and only, mind it, if storage was available by AWS, which is available, we assume that. And after that, what you do? Volume is created, and after that, volume you mount to what? Attached to, sorry, attached to what? EC2, correct? No? And after that, that volumes you mount inside a EC2. This is what you do, correct? Now, hello, hello.
Yes, yes.
Yeah. So same thing we do in the Kubernetes also. In Kubernetes, you go to Kubernetes platform and then create a volume. This volume creation, we call it a PVC. Okay. So create a volume. This called PVC. Now PVC will PVC means claim. So you claim the volumes, and after the claiming the volumes, you get the volumes PV. So
Mm,
request is PVC. Getting a volume is called PV. This is the difference. And after that volume which you got it, you can attach to the EC2. I mean EC2 means sorry pod, and mount inside a container, because ultimately the container will be using that PVC, right? So this way you can introduce the persistency in the pod. So let's say if the pod is gone, container is gone also, but PVs will be there and it will be using reusing. So the question is, how do we create a PVs and PVCs? So let me use some of my examples. PV, PVC. Here, host path. This is the tutorial I'm using. So how do we create a PVs? I'm just checking more simpler one. This one. Okay. So here, how do we create a PVs? So let me show you here the first PVs. QCTL. get PV, no, PVC, no. So how do we create a PVs? Here I'm creating a PVs. See, the kind is called persistent volume, and this data will be stored here in the worker node. 1 GB of PVs I'm creating. So this is the PVs. So vi pvs dot YAML, save it. kubectl apply PVs, kubectl apply PVs dot YAML. And you see here, get PVs, PV. If you do, see PV is created. Like that, you can create a lots of PVs, pool of PVs like that, multiple. Automated way also, storage class it can be created, but right now not talking about. So it's available. So now what to do? I am going to create a PVC. So PVC means claim. So you are claiming it. So this is a volume, real volume available. This will be done by administrator, but this will do the claim of 1 GB. So here I created 1 GB. I'm claiming also 1 GB. So here vi pvc dot YAML, save it, and kubectl apply hyphen f pvc dot YAML, kubectl get pvc. See here pvc, you got it. See that the moment you see that pvc claimed it 1 GB, so it bounded actually. See here. So that means this PV which was available used by this PVC. Now this PVC you created, look at the flow here. So you got the PVC, PV both. Now you attach this volume to the pod. How do you attach? So look at this. This is a pod. Kind is equal to pod, and here volume attachment is happening here. So name of the volume is PVC. PVC path. Look at this. This is the name of the PVC. Here attaching and mounting inside a container here. So this volume which you're mounting inside a container here. Okay. So now see that. Let me vi pod1.yaml. Let me create one more pod. kubectl apply pod1.yaml. Sorry, done. So here you have a PVC. Uh, get
Eh,
pods. Get pods. So see here, this is the pod, and I will kubectl exec this one ls. What is the path for this container here? So in this file, there's in this location. Let me show you what we have. Enter. See, nothing is there. Now I'll create some files. Touch this some files index.html. Enter, and you see the file is available. Now this file typically it will go inside a container. Here it is, and but it will go to the PVs under the temp devops code. So let me check this. Uh, um, ls temp devops code. See here, this file is here. Now what I'll do, delete the pod and you see the persistency is there or not. So kubectl delete get pod, delete pod, and I deleted, and you see that data is still there. kubectl get pvs still there, pvc is still there. This claim you can attach to the some other pod, replacement pod, and you can use it. So that way pod is gone, data is persisted. Are you understanding, all of you? All of you?
mm,
Yeah. Okay, so this is the demo. I want you to practice it. You have to create a namespace. You have to create a pod. You have to create a deployment. You have to create a service. You have to create a PVs and PVC. So pod means compute. Service means load balancing. Deployment means auto scaling group. And PVCs means storage. So you have to practice it. There are many other resources out there, but these are the most important one. Practice it. And again, in LMS, we have a in-depth video on record on Kubernetes. Around 20 hours of recordings are there, recently recorded. So if you have a bandwidth and if you want to deep dive into the Kubernetes, just check it out also that. Okay.
Okay.
Okay, I'll see you the
If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.